Yes. I think we ought to.
Can we talk?
No, the bottom, not the top. That's
No,
the
no.
top, yeah.
Can we talk about epsilon again?
Yes.
Like the very next.
Okay, so you new session, and so I'll remind you how is the test built. And for linear, remember that the points were not written on the exam, right? 4 is 20 points. Each section is 10, basically. It's 110. And here, the structure is 5 questions, test, exam. And 5 questions, each worth worth 22 points. Okay, and the subject are as such: 1 is limits, 2 is series, 3 is sequence with recursion. Recursion. Okay, recursion, and 4 and 5. I can tell you a bit of a hint. It's not really a hint, but 4 is more of analyzing, and 5 is really more theoretical. When I told you before, I told you that both 4 and 5 are the more theoretical. Yeah, I think that analyzing. Okay. I think the analyzing is still a bit more theoretical than other stuff. I think by its nature as well, because I don't. I don't need to say more. Yeah, I've shown you tests with these kind of questions. That's the type of thing. You need to think about it. It's not like Bagrut that you go 1, 2, 3 and then you're done analyzing. I'm asking question about the function, and you use analyzing tools to solve. Thomas. Yes.
I was thinking, can you, like, as a first thing, put links to the test you would recommend us solve? Because, like, I know that Hedva 1,
Come again, I didn't understand anything.
you can, like, as the first thing, put the link to the test you recommend us solve, because Hedva 1 has a limits, sequences with recursion, maybe an analysis.
Do again the links, that's what you're asking me to?
Yeah, no.
Because it sounds like you know them. I'll do it gladly, but
I know Hedva, but the thing with Hedva is the series in Hedva use integrals.
no, there are there are not series. There are no series here. Okay, fine. I'll do that again. In the following link.
Basically, what you would test exams are the closest.
But there is no exam which is exactly the same. There are some, but I'm trying to get you to a huge amount of that. So in the following link, questions 1, 3, 4, and 5 are relevant, which is everything but series. Everything but series is being covered by 1, 3, 4, and 5 in these tests, and there are a lot of them. Okay, some may be harder than others, but still, that's the material, right? Limits, that's an analyzing question. Then what? And here you can see why I'm saying these kind of questions are more theoretical. Find a value of the parameter such that f is not differentiable at some point x, right? It's not a high school analyzing, it's a university analyzing. Okay, 4 is the more theoretical one. Some of them are hard, and some of them are less hard, but they are all relevant. Everything that does not include integrals if we did not have it all. So if the theoretical question has integrals, feel free to ignore it. Most of them, I think it's analyzing theoretical. What I gave you is also more analyzing theoretical, I think. 5 is the sequence, and 6 does not matter. So again, to be clear, question 1, 3, 4, and 5 are completely covered by these links. 40 some tests with complete solutions. The only problem, so-called problems, is the series part. And then we can go to the exams that were there. And the first page, these ones. So you can go, so ones that are mine are usually more close like this. This is kind of close.
Ouch.
This is kind of close to your structure. Limits, series, sequence, theoretical analyzing. Okay, that's more or less the structure of your test. Okay, and so this was Tash'az. There were 3 tests this year, and they are all from the same structure. Okay.
Does it say whether it's from you or not?
Whatever is from me is usually more structured. Other lectures usually go like this. Say 1 is prove a theorem from the lecture. Fine. 2, that's a theoretical question. Fine.
Remember the
3, it's about a series here and that you can solve, but it won't be the same if I open any other test. They are much less structured. I'm not sure if it's good or bad, but that's the fact. And like this is super easy question.
For sure.
It is, but whatever. So you can solve other tests as well, but I think you're better prepared for me, right? And for the series, that's the only problem. So we have 3 tests here, 3 tests here, which are mine and really close. Let's look at this one. This has nothing to do with me. Deme is mine always, so that is also mine. Moed Aleph. That is not mine, but that's kind of close. Whatever. You have things to prepare for. If you want, we can solve things from that today. And that's the structure. Now you need to do either one of the two. And give me specific questions.
So
Or tell me 1 to 5 which subject you like to start. And it's not like you choose one and I go the entire prep session on it. We'll start with something and you can choose other ones later. Sammy wanted to say something. Yes.
Regarding series, how if that's not always supposed to study for.
What? Come again?
How would you recommend we study for series that are no practice?
There are practice tests.
So there are practice tests with
Yes, I told you these 3 at least, and that one. All of these has question with series on them. I said the most similar are these 3 from Tafshin Zayin. This is exactly the way your test is structured, but there's a huge amount of exercise. I don't think that would be the problem. There are more places in MathWiki. By the way, there are these tests. Some of them are also mine, by the way. Is there a series here? In a series. Oh, all of these tests on the first page, just not structured. So you need to go over it and look for the series questions.
can you
In
just
opposed to Andasa, which is question 1, 3, 4, 5. That's it, but you have a lot of, we can do it today, but then we have a lot of questions with series on this test.
Yeah.
There's another one.
Can you
Yeah,
just repeat
and
the name?
and just one last thing. Series here. I'll give you this link in the following link. There are many questions.
The other place.
רגע, תרגילים פתרונות. That's 13 fully solved horrible questions about series.
Mhm.
So you have a lot, you have a lot.
Yes.
Thank you.
Fun.
Yes.
Can you also just click the link to this, like the general thing, or how can we find it? Just like go back from.
What, this or the first one, I'll copy it, yeah, but that's the main one. That's the page which is called Chedva 1 on the whatever.
Yeah.
And copy.
חדווה is just חשבון דיפרנציאלי ואינטגרלי.
ואינטגרלי.
זה
אינטגרלי. Differential and integral. Also on this link on the test. Okay, so these are all the links. You have more than you will be able to solve. And if you will solve everything here, you're supposed to get 150 points on the test, which is impossible. Okay. Any questions? Any other questions, like technical questions, as to how are we supposed to study? We only have all the material and many exercises. Yes.
But we don't have this time.
Or motivation.
Yeah, or I decided to leave at this point. I mean,
Can you give me a reason to live? I looked through all the math wiki. I didn't find a single reason to live. Yes.
I agree.
no, not to
To
leave.
live. Yes.
Well,
So I think limits.
No, live. L-E-A-V-R-E. I have a reason to
go
go
out.
away. Live this place.
I think
I mean, no one better works for
is
that.
focus.
Yeah,
So
whatever.
for limits, I think we basically beat them to that. Like I need to practice
I agree. I mean, it's really easy to read yourself the limits parts. I agree.
yeah, just I have to remember all the rules of derivation, but apart from that.
It's calculus. I need to know how to derive. Yes.
I mean,
yes.
yeah, just
It's
do
true.
the hospital 5 times and like
Yes,
that.
yes.
For trigonometric functions, do you expect us to use identities or?
Yeah, like I told you in the lecture, the hardest identities to remember are these, which I expect you to remember: cos A, cos B minus sine A, sine B,
Yeah.
and the same for sine. Sine A plus B is sine A cos B. Ever since cos B, sine B cos A. I keep thinking about the Rohypnol number with this, yes.
This is because of the derivation.
Yes. And the other ones are like cosine of minus x is cosine of x, cosine of minus x is minus sine of x, and Pythagoras sine x squared plus cosine x squared is 1. So there are like 5 identities. I told you in the class about geometric functions you need to remember, and nothing more exotic than that.
So we don't need to know tangents and tangents.
Alright,
You need to know the tangent in sine over cosinus.
No.
I'll admit that I'm actually cheating you when I'm saying that, because my point being is that every other identity derives from these. So it won't be too exotic, but really that is the case.
I'm asking as I was Going from the as
Yeah.
there was a question where to know the identity of the cotangent, I think.
You're going through the drive or through his
The
steps?
drive. I know
Okay,
that's
the
the
drive.
mistake.
Yeah, no.
Like making mistakes.
I know.
Yeah, I saw a couple that were talking about the cotangent and like the arctan.
Yeah.
But tangent is 1/tangent. I never speak about it, but that's it. But I will never mention it. You do need to know, I don't think I would put it here, but you do need to know the derivative of arctan of x. I don't even remember if I actually asked about it, but one should know that. That's really important for calculus. I don't remember if it's in the test or not, but you should know that. I really don't.
You also need to know which ones are bounded and which ones aren't.
Yes, you need to know stuff, yeah.
You need to know stuff.
You need to know the elementary functions and their derivatives, yes.
Elementary dear Watson. Anyway,
Yes.
series. I think series is like the hardest part for like.
So I'll start with series. I don't think it's the hardest part. I think it's the easiest one, but I might believe that you are not well prepared for it, or you're so not well prepared for the other part that you think it's easy. But whatever, I'll start with series and do some series. Great. Yes.
Before we start, can I just ask a question on the formulas that you just wrote?
Yes.
When you said that everything derives from that, what do you mean?
Not just that, also Pythagoras and whatnot, but most identities derive from the basic identities, like sine of 2a, sine of a plus a, right? Sine of a minus b. You simply plug in minus b instead of b. And cosine of 2a is cosine squared minus sine squared. And now you can use Pythagoras to go over other stuff, and you get half an angle. And most identities come from this.
And how did we get that?
So which one of them? Like I said, 2a is a plus a, right?
No,
Minus.
How did we get this formula?
No, these I never proved them.
Oh, you just.
I never proved them. The proof is geometrical. I never showed you.
Yeah.
I just tell these are the only ones I don't show because it's too much geometry and has nothing to do with calculus. Okay.
Too much geometry.
What?
There is such a thing as
For calculus, I didn't say it's hard or it's a bad proof. It just has nothing to do with this course.
So look at it in Khan Academy. I saw it in Khan Academy and I forgot it.
Yeah, exactly. I also saw the proof and forgot it because it's not that interesting. It's kind of like a structure with a triangle. And
Yeah, it's a really like
it's true. Yeah, it's
five
not.
triangles and like.
Yeah, I remember proofs that has deeper meaning, or I understand their deeper meaning. Here there is one.
Triangles.
Yes, yes. Okay. And by the way, if you really want more questions, there is this link over here.
Okay. Oh yes, I started doing it. That's so awful. I hate it.
Yes.
It's so much.
Yeah, so it's like 71 questions with full answers I did.
Just had to do 71.
Yeah. No, I just it's not exact number. Every time I find a nice question, I add it to this file.
71 is a prime number, so it's fine.
Yeah. But it happens when I gave a test for on the engineering, and they annoyed me. They say, "Oh, you're more theoretical than our other lecturer. We don't have anything to practice from." So I created this file. Say, now you can practice. And now everyone says the horrible file. Other lecturers do use it as well. Elad tell his students, I will put a question from this file. Some people tell the TAs tell the students never open this file like it's Kabbalah or something. He'll go mad. Okay, fine. And this is less relevant. And these are more tests. This is nonsense. Oh, and there is also tests from other universities. Okay. So, okay. So let's do something with series.
Maybe you should start a course 5 with series instead of Sidrot.
What?
Maybe you should start the Kurtz file of series, not only Sidrot.
Yes, no, but in the file, there. Oh, I didn't because it's Handasa. They don't study about the series. But I did make something like that. First of all, that's the link with 13 examples. It's
Ah.
kind of like the same thing. And another place, the problem is that does not have answers. Although today with ChatGPT you might not need. Here you have these three, no, these two files. Let's give you a link for that as well. And there are nice questions here as well. Problem is just it's without solutions. And I'll open,
I'm sure some AI will solve it.
I'm sure 03, but not 40. And
Or it works pretty good.
not in Matthew.
I usually just put it.
It
for-
depends if you care whether the solution you get is fast or true.
You told me to
Because it's
fast.
very quick. It's very quick to write nonsense.
You're very quick. I'll give you that.
Yes, I can do quick math, but it's wrong, but it was quick. Okay, yes.
Pay $20 as the test.
Here until wait. Here is just question number 1. Okay. And question 1.
Some of them need integrals though now.
What do you mean need intervals? I don't
Like
know
I,
what you're
some of the
talking about.
solutions to the questions I saw from the Kedva ones.
I think it's טורי פונקציות, they're not טורים. It's not series, it's function series. That's the point. That's what I think you said. It needs interval. Okay, so I think we have enough. And maybe also some of these. Okay. Does anyone anyone caught your eye?
I mean, I saw one that isn't that is.
By the way, quick look. There is something similar here, something I put on the test, so that's you really should solve these things. Okay, let's start from this though. I do this. I like this one. I like the second one. I don't remember how to solve the third one, or maybe I do know. Whatever. Let's start with that. And I'll tell you, this is and this is a theoretical type of series question. What does that mean? It's not the type that you have on the test on the second question. It might be on the 4th or 5th question, which are more theoretical. Okay? But I'm going to do it nevertheless, even though this won't specifically prepare you to the test, because it's a warm-up of talking about series, about positive series, and remember the rules and convergence, right? After that, I will go over like the algorithm of what to do if I'm asking you to decide whether it diverges, conditionally converges, or absolutely converges. Okay, so after that, I will do the algorithmic one. But that is warm up. But in your test, such a question, if it would have been appeared, it would have been in the theoretical part, not on the second part.
I think I saw this question before.
Probably.
The first one, I think it's true. Simple.
It's proved.
I mean, then it's true. I mean, right,
It's
but-
better than Sammy when he thinks it's true and then he did prove it. But yes, it's הוכיחו.
Okay, cool.
I think it's true. Yes.
I'd
Okay.
like to think it is in fact true.
Okay. So the point being as such, I'll just go over to the solution. Solution. First of all, you need to notice the following fact. The difference between an and bn squared is obviously larger or equal to 0. Do you agree? What I'm doing basically, by the way, this question has to do with the algebraic average versus the geometric average. What I'm doing basically is proving it in the case of two elements. I'm not sure that it was helpful to say that, but that's true. And now we get an squared plus bn squared minus 2 times an bn larger or equal to 0. Agreed?
Yeah, because of the how's it called, the triple difference or something.
I just open up the parentheses.
No, so okay, but
Kefir
like,
mekutzer in Hebrew.
yeah. What I say is that falls from some other theorem we saw at the start of the course.
That's what I said about the average, the geometric versus algebraic. But that, because it's just for two elements, then it's quite easy. If I would have asked you this for a same question with a K series, still be true, but it will be, you will need the averages theorem to do it, AMGM. Whatever. So what we get here is that A and Bn is smaller than an squared plus bn squared over 2. And why is that important? Now read the questions. My assumption is that an squared converges and bn squared converge. What is the sum of two converging series? It also converge.
And multiplying by anything.
Yeah, multiplying by a scalar or dividing by a scalar is meaningless. So since the sum of an squared and the sum of bn squared both converge, then so is the sum of, on the right, an squared plus bn squared over 2. And why does it help me that this converge?
Because a times b is smaller.
Because this is smaller and these are positive series. So the smaller positive series must converge as well. Grid?
Yeah.
And just to be honest, if the problem for me with this question as to give to students is it started with that, and you would rightfully ask me, I would tell me I would not have thought of that. So for me, if I put something like that on a test, on homework it's fine because on homework you have time to try stuff. But if I would have put question A on the test, I would give you a hint to use that. To look, my hint would be look at the expression and give this expression, and then you need to fill in the blanks. Okay, but so don't feel bad if you say I would have thought about this inequality. Yeah, it's not the first thing that comes to mind, but when it's given, it's pretty clear as to how to go about this exercise. Question number 2 here, without section A, would be impossible. I think I tried to solve bet without Aleph for some times and failed miserably until I got to use A, and so I remember it badly. because I'll tell you what is going on basically. The sum of the squares converges. What is the connection between the sum of the squares and between the squares and the actual series? Who is bigger, an or n squared?
Depends on,
But this series is converging, so it doesn't depend. What does it mean that the series converge? It means that an tends to 0. So when you square it, it becomes smaller. So the series with an is bigger. That's the problem.
They can converge
But-
to a number that isn't zero.
What?
They can converge to a number that isn't zero.
Yeah, but the elements of the that you sum up goes to 0. The sum is not 0, but the an themselves are 0. Okay? So you take a bigger series, but you divide by n. So it's bigger, but you the division by something divided by something, so it's a bit smaller. And you have no idea as to how does it go with n. And it seems, I think I tried to disprove it for a while, because it seems like n is so random. How am I sure that specifically n here will make it converge if I know nothing of an? Okay, so in itself, it's a super hard question. With section Aleph, it's not that hard if you think about it. Yes, Thomas.
I'm thinking the biggest possible series, like where this works, is like
There is no such concept as
I
the
mean-
biggest converging series, because whatever series you're thinking about, you can double it. Still converges. There is no such thing
I mean,
as the biggest converging series.
Yeah.
That's the problem.
I
here.
know. I mean,
Because you would like to go to it. You say, assume it's converging, so it's the biggest converging, and then you get, but it's not a way to solve things, sadly.
Yeah, but wouldn't it always be a BFF of 1 over n to the power, like the square root of n or something?
No, doesn't have to be.
Mm.
Because even if you took these kind of things, you can multiply by ln of n, like 1 over n times ln squared is converging. So it's a bit smaller than 1 over n, and it's converging already. There is no such concept. Okay, so can anyone think how to use safe Aleph to solve safe bet?
You can make two series. It's an and 1 over n.
Exactly. You simply plug in bn equals 1 over n, and then it follows immediately. That's why it's so surprising.
I think we did this in a homework, but I'm not sure.
Could be it all stems from the same thing. So for b, choose bn equals 1 over n. It is true that the sum of bn squared, which equals the sum of 1 over n squared, it's not what I needed to write, 1 over n squared, is converging. Then by section A, there are better words. Section sounds wrong to me.
Question.
Part,
Question.
but it's not a question. The question in
Subs-
Hebrew
subs-
we say question too, and then seif aleph.
I mean,
Oh.
subsection.
Just do it.
Part
I would put
What?
subsection.
Part A.
Part.
Subsection.
Just put A and put it in brackets. And that's the biggest one.
They're all sound, I don't know, not good to me. Subsection, I think that's it's funny because it's more words, it's more letters than section, but subsection.
Oh, wait, let's just choose part.
I have a solution.
Part A. What? What are you showing me?
I mean, it's not exactly the same, but it's right.
Well, it looks the same.
Yeah, I think.
No, it looks the same. Part A sum of A and Bn, which equals the sum of An times 1 over n, is absolutely converging. And here there's an interesting thing you need. No, it's already with the absolute value. But if the absolute value wasn't here, we would have needed to know that if the series is absolutely converging, then it's converging with the absolute without the absolute value. And that's it for for B. And part C, did you have it in the homework as well?
No, we have another one. I'll tell you what it is later, but no,
Okay.
it's not good.
What you showed me, it was from the homework?
Yeah.
I didn't understand. Show me. It looks the same.
No,
I looked at the
second one-
proof. I thought you were showing me the proof, not the question.
No, the
So
first
what's the
one,
question?
this B and C are the same. A is
If they are both diverging, that the multiplication diverges, obviously no.
start.
If B is exactly A,
And C is B.
and C is exactly B. Yeah, it's
Yeah.
the same question.
Yeah.
Same exact question. No difference whatsoever. Okay, C is something different. Okay, so we need to prove that AN converges if and only if AN over 1 plus AN converges. So let's solve C. Part C. We have a bidirectional argument. We'll do one direction, then the other. First, assume sigma of AN converge,
Wait, what's the question asking?
and we'll prove, I'm writing it, that sigma of AN over 1 plus AN converge. Remember, AN is bigger and smaller than 0. Positive series. Okay, it's important because I'm going to use it a couple of times, to be honest. Okay, what can you say about AN over 1 plus AN?
That it's smaller than 1.
It's smaller than 1, that's not enough. What is it smaller than?
And
AN. That's for the first time I'm using AN is positive because the denominator is bigger than 1. That's therefore I write it because the denominator and 1 plus AN is bigger than 1. Agreed? Therefore, by the comparison, oh,
1s and O without an I.
comparison. Okay, by the comparison test, comparison, and therefore by the comparison test, for positive series, the second series indeed converge. Okay, so that was the easy part. If the bigger of the two converge, then obviously the smaller converge, and because we divide by something bigger than 1, then obviously this is the smaller one. So that's the easy part. To prove that from the convergence of the smaller one, if it's true that the bigger one converge, that's a bit more problematic. Okay, agreed? Fine. Now, next, assume that sigma AN over 1 plus an converge, we need to prove that sigma n converge. And the first comparison test is obviously irrelevant because this one is bigger. What other tests do we have? It's positive series, so it's Spock test. We did one comparison. What is the second one? Limit comparison. Let's try. And it's obviously, by the way, it's the only way possible because what will I do? I'll take the ratio test. I have no idea what the ratio of this sequence is. Root test, the condensation test, it has to be the limit comparison, but that's not proof, just logic or reason, not logic. And let's try the limit comparison test. So we divide one by the other. So on top we have the first series, which I know converge. And then the bottom I have the second series, which I want to know about. What does that equal to algebraically?
An over an plus an squared.
That's true, but silly.
1 over
1 over 1 plus an, yes.
Can we not do it the other way around? Yeah, 1 plus a.
You can do it as well.
And that tends to
Wait, why does it tend to infinity?
not be, not 1 plus beta.
So that's the main problem. Where does it tend to? That's exactly the problem. How can I know what was 1? What does 1 over 1 plus an tend to?
because
Then-
an is positive.
Wait, sorry.
Why do we need to know where it tends to? Can't we just do the?
That's the limit comparison test.
But can't we just do the squeeze again on it and say that's smaller than n over?
Yeah, and a over 1 plus a tends to 0. Merges, so,
So
and it's bigger than 1 over. And
what are you saying? Are you saying that this is actually bigger than an? Because we know
No,
for a
no.
fact it is not.
no, an over 1 plus an, it's bigger than 1 over 1 plus an. But an over
1 over 1 plus, but who cares? That's not a series I'm looking for.
Yeah, but if this tends to 0, then this tends to 0, and if this tends to 0, then both converge. Question.
Not both converge. If this tends to 0, then the numerator is smaller than the denominator, a fact which we know, and not helpful at all.
So
It tends to
Luckily, it does not tend to 0.
but in the limit comparison.
Because it would have been a problem if this tends to 0.
In the limit comparison, if it tends to 1, it's undecided, right?
No. So yeah, that's why I wanted to do it, for you to warm up your engines with series. The test says that if the limit is any number, finite number, which is not 0, they are BFFs. Any number. 1 is like the best number, right? Because there are like
in 1 conversion.
Yeah. the bigger than 1 and smaller than 1 is the ratio test and the root test. It's not the comparison tests.
Oh.
Okay, different tests. So again, I hope I convince you at least that we did not solve the question. But in order to do it, we need to calculate the limit. That's the idea. I'm taking one series, the other series. I take the quotient of these two. I find the limit. And if the limit is a finite number different than 0, there are BFFs and we're done. If the limit is 0, it says that the numerator is smaller than the denominator. And now I'm thinking about Terminator. And I'm watching Die Hard. Okay, sorry. And then you get the first comparison test. And if the limit was infinity, it would mean that the numerator is bigger than the denominator. And then again, you do the first comparison test. So you would like any finite number different than 0 if you can get it. What is our main problem here? we have no idea what the limit is whatsoever anyway. We don't know what the limit is.
But AN goes to zero now,
Why does AN goes to zero?
because, right, because we don't know if it converges.
Because we wish to prove that it's converging. So assume we proved it, then AN goes to zero, and then we proved it. Right. Okay. So yeah, no, so that's the problem. Now I'm going to solve it. Okay. So I'll solve it with my favorite way. Wouldn't it be nice?
Point.
Okay. So wouldn't it be nice? Wouldn't it be nice that it was AN? Yes. AN over 1 plus AN. Do you agree that would be nicer?
Mhm.
Because I know something about it, but it's not. How can I fix it?
Multiply it by AN.
So I can multiply and divide. That's not the way that will help me here. I'll subtract. Do you agree with that?
Yes.
AN minus AN is zero, Thomas. Do you agree?
Ah.
I think it's zero, yes.
Yes.
Good.
Okay. And now,
Can I show you? After you solve this, can I show you?
yeah,
this?
after I saw the question, I saw the limit you think it is wrong. Then okay. So we have,
Minus AN plus 1 over 1
wait a
plus AN.
second.
It works.
Yeah, but it's a bit, I need the minus here, which is a bit surprising. But I need the minus here. Plus 1 plus AN over 1 plus AN. Do you agree?
I mean,
That was counterintuitive for me. I took the AN out. It was the wouldn't it be nice that I added. But then I saw this would be minus, and I have nothing to do with it.
Mhm.
Right? But if I take the minus here, it's fine. Why? Where does this tends to?
um, 0
Zero. Why does this tends to zero?
because it converges.
Because this converges. Okay, I'll write it here. Since this converge, then AN over AN over 1 plus AN goes to zero, right? What about this?
It goes to 1, but
It's 1. It equals 1.
it equals 1, yeah.
It doesn't go to its
So the
equal
whole
1.
thing test.
1. Yeah. And that's good. That's what we wanted.
I mean, if it works,
Therefore, just a second. Therefore, and the two series are BFFs, and sigma n converge as well.
Can you show me where I'm stupid?
Yes.
that's his favorite. That's his favorite.
No, I
part of
went
the
like
show.
this all
I
over.
know.
Yes. And over one. What do you mean one goes to AN?
No, 1 plus AN goes to 1.
Why? That's the problem. It's the same problem. Why does 1 plus AN goes to 1?
Oh, that's where I'm stupid.
That's the limit. That's the
That's-
limit we don't know how to do.
That's what I'm stupid. Anyway,
Yes.
this wouldn't work if it goes to -1.
It would never be because it's the spot tests are just for positive series.
Yeah.
So the limit must be always bigger and smaller than
You
zero.
practice things that they're.
I don't need a mirror to practice doing it. And I don't need to practice it
Every Star Trek convention.
too much. Yes. I'm not a Trekkie.
Can you do it on your own?
Yes.
He does the same that.
No, it's like I teach calculus for a lot of years. Obviously.
That's
You move
very.
his ears.
Yes. What?
You
Yeah. Like moving them.
Do you know that the people can't the muscle that does that actually atrophies? It's useless.
Yeah,
And if you just.
but I can only move my right eyebrow and not both of them. Not the other one, I mean, both of them I can, but not the left one. Yeah. But yeah, it's kind of stuff you don't know about people. You go to the army, and when you shoot, you need to close one eye. And some people are not able to do this, and it's outrageous. And probably someone in the class now is offended. But it's the first time. So the told to put your hand over your eye when you
Or an
shoot.
eye patch or something.
Yeah. Arr. No, but
The reason that you don't just close this because not to straight muscles.
no, but I'm talking. I agree, but I'm speaking about people that cannot. I saw in the Tironot people who could not squint one eye.
Well, life.
Yes. Okay. Fine. Fine. Let's get back to calculus. Okay. So now the algorithm. Algorithm. Where? Oh, okay. The algorithm
What
for
the hell are you doing? Move to somewhere that is
I just
below
turn
the
it down. Just turn it down.
We can have a second film.
If it gets hot, we'll find a laptop in there. I don't believe you need to
when
have.
Tomas will start punching your face, it will be hot. Anyways, okay. The algorithm for answering a question of the type find whether
I think we wrote this back in.
I'm sure I did. I tried to teach you. This is a review session. We're reviewing to find whether it's not the way. That's the weather, right? Where like that.
Without name.
Yeah, then, yeah. Not the weather.
Whether
Yeah.
the series converge conditionally, absolutely
Or the verb.
converge or diverge. So one, it was 0, but if an does not tend to 0, if I'm sure that the limit is not 0, then the series diverge. 2. Do the 5 Spock test on the series of absolute values. 3. Use Leibniz or Dirichlet or the
Telescoping.
the partial sums sequence. Okay, so that's the whole thing. And step 2 is like the biggest one. Usually most of the work is step 2, but not always. Okay, and now let's take one of these. And these are almost all positive, huh? I didn't know this is not a positive series. It's an exercise about positive series. But I can always add -1 to the n and make it interesting. So let's start with that. Examples, and we'll do a few examples. So let's look at the sum when n goes from 1 to infinity of -1 to the n ln of n over n.
Mhm.
Okay. So using L'Hopital, ln of n over n goes to 0. Okay, it's infinity over infinity. You derive it's 1 over n over 1. It goes to 0. And so this does not, this does not help us. If the series goes to 0, the sequence, sorry, goes to 0, it's meaningless. Okay, if it doesn't go to 0, then the series diverge. But if it does go to 0, maybe the series converge, maybe diverge, maybe absolutely, conditionally. All options are open. That therefore it does not help us.
This is the
No, I mean,
Wait.
yeah, first,
You don't skip steps. You cannot, because if you use Dirichlet, you show that it converges, but you don't know whether it conditionally converge or absolutely converge. So don't skip steps.
so
Yes.
we compare its absolute value to the.
So next we take the absolute value. Yes, Sammy.
why when you're doing L'Hopital, do you not include the -1 to the n? That's not part of AN as well.
Because sequence goes to 0 if and only if its absolute value goes to 0.
So
So I don't care about it.
go further up.
What?
Go further
Yeah.
up. Maybe you should do the absolute AN.
It's the same for me. No, you can do it if it helps you. Because for me, when I see an goes to 0, I know it's equivalent to the absolute value of an goes to 0, and I can choose whatever is more helpful to me at this time. Okay, I can write it. I don't mind, but it's important for you to know that it's the same.
What do you mean it's the same? I don't understand.
An goes to 0
Okay.
if and only if the absolute value of an goes to 0. These are equivalent statements. It's a theorem we learned in a long time ago, far away.
When we were still happy.
I think it wasn't that far away. I think it was and you were never happy. Okay. You came to me after Dida, you didn't come happy. Okay.
It wasn't that, but I mean, it was pretty bad.
Yeah. What do you think it was harder, Dida or linear?
Yeah, like,
Yeah, okay.
but Adi wrote it in.
Yeah, that's what she says. She says that her Dida was much harder. Okay. So,
That's
so
good at these, but yeah.
Yeah, you don't know?
No, I thought.
it was just
I
you?
thought Ari
No,
wrote it.
no, because Ariel taught us, Ariel Foran.
Yeah.
And like,
But the test was together, yeah. Yeah, okay. So this does not help us. So what do we do? Next, we consider the series of absolute values. So in this case, it's simply ln of n over n. So now either comparison, limit comparison, ratio, quotient, or condensation. Okay, what do you think?
comparison with
Yes.
1 over n.
So the LAN is confusing because you might think condensation, because a lot of time the LAN actually goes to condensation. But here, if you think about it for a second, it's bigger than the harmonic series. LAN of n is bigger than 1. Maybe not for the first two elements, but from the third one on. Okay. Therefore, the series does not absolutely converge. Okay? So now we finished because we guessed it correctly on the first step. Now we wish to do the Dirichlet or Leibniz, which are more or less the same. They are not the same. Dirichlet is more general, but we can think about it as Leibniz as well. So now we wish to show the series does converge and therefore conditionally converge, because we've shown it's not absolutely converging. So if it converges, then it's conditionally converging using Leibniz. And what do we need to prove for that? We need to prove
It's decreasing.
that ln of n over n goes to 0. We said that.
Mm.
And ln of n over n is decreasing. And the question is how to know that it's decreasing. So I like this example. I don't remember if I've shown you this. Do you remember, Thomas?
What?
If I shown you this specific example of ln of n over n,
I know I've seen it, I don't remember it.
how do you prove that it's decreasing?
I mean, I think
Isn't it because
you do.
n is way bigger than n?
No,
That's not good. Why?
Oh,
So-
right. Sorry about that.
The ratio here is not very helpful. If I'm helpful. If I'm looking at a n plus 1 over a n, I get ln of n plus 1 over ln of n times n over n plus 1. Not completely sure what to do with that. I just had an idea now. No, it doesn't work.
I mean, the difference also doesn't work.
Yeah, the comparison between a and n plus 1 doesn't work.
Wait.
That's my point.
Do you derivate it and see where it goes?
Exactly. But we are in a calculus course.
Yeah.
Yes. We know how to analyze function.
We should.
Look at f of x equals ln x over x. What's the derivative of f of x?
1 over x, we said.
What?
We said 1 over x.
What 1 over x?
Is it not? Wait.
Ln of x over x, Thomas, that was horrible. Let's ignore the denominator, it makes it confusing. Just ln of x. 1, it's the derivative of the numerators times the denominator minus the derivative of the denominator times the numerator over the denominator squared. You're close. So that's 1 minus ln of x over x squared. Agreed? When is it negative?
When ln of x is bigger than 1.
And when does that happen?
After 2.
After e.
After e.
After e. Right? Because ln of e is exactly 1. Agreed?
Mhm.
So f is decreasing at e to infinity. Therefore, for every n bigger than 2, it is true that f of n is larger than f of n plus 1 because the function decreases and the next numbers will be smaller. But that exactly means that ln of n over n is bigger than ln of n plus 1 over n plus 1 and QED. Okay, by Leibniz we are done. The series conditionally converge. Any questions so far? I really like that question because it's so chedva. You know, always in chedva, both 1 and 2, sometimes students need to find where something is increasing or decreasing or find the maximum and say, how the hell are we supposed to do that? And that's like supposed to be the basic stuff in calculus. But I do get is how it's not the first thing that comes to mind, because this is sequences and not functions. But nevertheless, functions are helpful.
Derive even if it's not continuous because we don't care.
Yes. Do you wish for more series or something else?
I don't know how crazy the limits you put in the test are going to be, but I
If
say
you know how to solve everything in engineering, you won't have a problem.
yes, I'm going to build a bridge next. But now like I started looking at it and it's like
Oh, you started looking. I like it. You didn't even look. You started to look, and then
oh,
your
no.
eyes closed
Yeah,
suddenly.
with tears now because
Yes.
because like I'll show you what I was doing. I'll tell you what I was doing and you can tell me I'm done later. So the limit of x goes to zero positive.
Example. Limit as x goes to infinity. 0 positive.
Yeah.
0 positive, yes.
Of 1 over x.
Yes.
And in parentheses after that, 1 over x to the power of x.
Yes.
Minus 1.
Okay, to solve it?
Yeah.
Great. Okay. So, first of all, what am I saying here? I'm trying, when I'm looking at a limit, I'm trying to figure out where does everything goes to. So x goes to 0 positive, so 1 over x goes to infinity. X to the x, I remember, if not I need to calculate it, but it goes to 1. So this is 1 minus 1, which is 0. So I have infinity times 0. Okay, and we need to do something. That's overview. Now, for my overview, one needs to know that x to the x goes to 1. So the question is, should we take it as an exercise to do on the side before we continue? And not necessarily, because we might do some algebra to it before we solve it. So I'm really am not sure as to how to go about it, but I'm leaning towards doing a common denominator here. I'm not sure if it's smart, but I'll do it. Okay. Where is this question from?
2023 model from
It's mine?
no from
Oh.
computer science.
Okay, because it's not Sometimes you don't recognize
Your own children. No, it's not one of yours.
Yeah. Okay, so again, what I'm trying to emphasize that I'm not sure as to what is the next step. What we need to do is try a couple of things until we solve it. In any case, 1 over x times 1 minus x to the power of x over x to the power of x, which is the limit as x goes to 0 of 1 minus x to the x over x to the x plus 1. Agreed?
Mhm.
Fine. So the numerator is obviously tending to 0 because it's 0 to the power of 1, which is 0. And the numerator, we must check. I'm not able to skip it. Not it's that hard, but in order to do L'Hopital, I have to know whether it's 0 over 0 or not. So I can't do L'Hopital until I check this. So I'll check it.
We can't just say x a0 to the power of 0 is 1.
No, because it's nonsense. 0 to the power of 0 is one of the problematic cases. Oy vey. It's just one. What's the problem? 0 times infinity, 1. Okay, it's not. So we have x to the x. Does anyone remember what we do when we have x to the x?
Ilan.
0 to the 0, exactly. So it's 0 to the 0. We do the Ilan test or the log rule because log is a type of tree. And we say the limit as x goes to 0. Don't invent theorems, Thomas. Of e to the power of 1 of x to the x. I'm saying 0 to 0 is 1. What's the problem? It's always 1.
No, I thought that when we started the course, we just said 0 to the power of 0 is 1. How would they?
We may have said that the actual number 0 in the power of the actual number 0 is 1. That does not tell us that something that tends to 0 in the power of something that tends to 0 goes to 1. And more to the point, or importantly, or I don't know what to say, we learned this. If you have 0 to 0, you need to do Ilan. You don't. Otherwise, I will say it's always 1. Don't do anything else. It's 1. You need to remember the problematic case. That's my point.
Okay,
All the problematic cases.
in particular, in this case, it's like if it's single value over a single value, it doesn't matter. But
Because it's the same, you mean?
Yeah, when if it's
That's what I will prove now, basically.
Okay.
Because I will calculate it it's 1, and then when you plug in anything like in Heine theorem of limits, when you plug in everything, you also get 1 if you plug in the same thing for the power and the base. But it's not like a theorem. So it's the limit as x goes to 0, positive from the right. I prefer to say from the right rather than positive, of x times ln of x, which is e to the 0, which is 1. But why is it e to the 0? What's the limit as x goes to 0 from the right of x ln of x? That is actually 0 times minus infinity. So we put 1 in the numerator and the other in the denominator. It's ln of x over 1 over x, which is minus infinity over infinity. That's why we can L'Hopital it. So we L'Hopital, and we get the limit as x goes to 0 from the right of 1 over x over minus 1 over x squared, which is the limit as x goes to 0 plus of minus x, which is 0. So easy.
Are you sure you don't want to do L'Hopital one more time?
Yeah. No, no, I thought you were about to say, are you sure you don't want to say it's just obvious that it's 1 and then skip the whole thing? Okay. So this goes to 1. So now I can go back to this.
And say, ah, yes, this goes to 0. Let's do L'Hopital again.
Back, yeah, exactly. Back to the question. We have this. So the numerator also. So that's 0 over 0. And we can do L'Hopital. But how do I derive x to the x?
I was having a difficult time doing that, and I still don't fully understand why we can't use the exponent rule.
Which,
Like you do -1 and you put it in front.
yeah, that's when this is a constant.
Yeah, when it's not a constant, it's a
And you're not
problem
allowed.
because
It's not the same function, it's a different function. Why, for instance, Thomas, why, when we derive sine of x, don't we take x to the side and multiply like this? Why not? Because it's not the same function, right?
fine, whatever.
Maybe we can take n to this. What's e minus 1? A, B, C, D, E, I. So that's we can happen. But seriously, we learned that the derivative of x to the power of a constant is a times x in the power of a minus 1. It's only for this function. X to the x is another function. Why would it have the same derivative? And we also learned, by the way, that the derivative of a to the x is a to the x ln a.
So I said, yeah.
So
we
now
think like me.
I wonder which one will we use here. But- yeah, together. And someone showed me once that the actual answer is kind of like both of them in a sense.
This is composite, isn't it?
It's not a composition of nothing. It's not a composition of these two.
Oh, right.
So after we had some laughs, or at least I have, what do we actually do? You need to remember, it's a function in the power of a function. What do you always do there?
The chain rule.
No,
Is that chain rule?
Ilan roll. You knew it just a minute ago.
No, yeah, but
So you do the Ilan roll. You say that's within that you will use after that you will use the chain rule, but it's not. So you say it's Ilan, right? Agreed?
yeah.
And what is important for you to know is that when you see a function in the power of a function, you always go to Ilan, both for limits and for derivations. So that's e to the power of x ln x prime, which is e to the power of x ln of x times ln of x plus 1, which is x to the x times ln of x plus 1, which is the sum of both these options, by the way, because this is a to the x ln a, that's x to the x ln x, and if you remove the x here and do -1, and then you multiply by the x, you come back to x to the x. So that's yes. But it doesn't matter because it's false. It doesn't matter.
No, that's exactly why.
Yeah. Because sometimes student came to me as a teacher in high school, and he showed me this, and so it's the sum of these two. Is there any reason for it? Like, I don't know. Maybe there is, but I don't know why it's the sum of these two.
I think they all both all follow like the same idea of the chain rule, and like that's why it works. Because like the first one is from the chain rule also, I think.
For Milan, yes.
No, but the first one.
This is also for Milan. Yeah.
Yeah.
It's not the chain rule, it's Milan that uses the chain rule. Whatever. That's the derivative. Okay? Next, we need to derive this lovely thing. So,
I think it's x plus 1 times x.
yes. Yes. Okay. I wonder if it will work here. And so, Ilana. What is that?
It's my attempt, and then I realized I was wrong. But the
So the derivative.
the answer.
Yes, nice.
the answer is infinity, not minus infinity. So I was almost right.
Where's my Word document? Okay, so it's e to the ln of x to the power of x plus 1, which is the derivative of e to the power of x plus 1 times ln of x, which is e to the power of x plus 1 times ln of x times the internal derivative, which is ln of x plus 1 over x. It does actually hold the same rule because it's x plus 1 times that times x to the x.
Is there a reason you're doing it then and not just chain rule?
What do you mean chain rule?
You
What is the composition here?
It's fx is x and gx is x plus 1, and it's 1 to the power of the other.
If f of x is x, what is f of g of x?
Is the other way around? I don't remember. I think you can just do it. But
You don't need to remember, you just need common sense and decency. If f, look at the question, if f of x is x, what is f of g of x? That's the identity function.
Yeah.
You're telling me this is a composition of the identity function and some other function.
I may be not.
You understand? It's wrong. It's wrong. So it's good that you keep asking me that. It's not good that you don't believe me. It's good that you keep asking me that. So you understand that it's not a composition. It's not a natural composition of two functions, right? Now, after I've shown you this, which I'm sure you learned in without, x to the x, what is the composition of what two functions in your opinion?
Wait, it's only one function.
It's the composition of itself.
itself.
No, we can. It is true, by the way, that you can look. So the derivative of the composition. I'm kidding, but it's both funny and math. So the derivative here is the derivative of f of g of x times g prime of x. Do you agree? What's the derivative of f? 1. So it's 1 times g prime. So that's true. You can derive it using composition. I would not recommend it. Okay. It's just assuming you know how to derive it. The rest is easy. Yes, it's not a composition. That's why for the power you have to use Ilan. X to the a as well. I don't know any other way to solve it. Okay. So
I know what we're doing this summer.
yes, yes.
One by every other day.
So, na, na, na. So we have x times x to the power of x plus 1 times ln of x plus 1 over x. And now we can go back to the question. It's a nice, easy question.
You should copy back to the question with the formula so you know to play it.
Yes, that's no, that's what I did. So
Oh.
back to the question.
Oops, I did it again. I
Yes.
did L'Hopital.
No, but it says don't derive the sum.
Yes. You definitely not. If someone had a gun to your head and said, right, you're gonna just shoot me.
For the love of God.
Yeah. It was both a lot of time and embarrassment. Okay, yes.
I just do L'Hopital, I don't know how to derive.
Yeah, that. Yes.
Thomas, would you like to swap places? If you're so hot over there, I'm
Yeah,
sorry.
I told you, go forward.
No, would you like to swap places? Is anyone else in here cold or warm?
I don't care to be
I'm
honest.
You're freezing?
Too sleep deprived.
Anyone else cold? Ariana's wearing a hoodie.
I'm cold.
So
Yeah.
Thomas should come and sit under here under the thingy where it's the coldest.
Just lock the door when he's out. No, but then will help me with the banter. No, I have Simon, that's true. Wait, where is the second derivative? I lost it. Oh, it's here, it's that's so small. Okay, so almost that, just to make sure. It's minus what? The derivative of 1 is 0, and the minus here will be minus. So we have a minus here. And the nice thing, and I'm optimistic for the first time, is what is the nice thing here? Can anyone notice?
I wish I do.
One.
What?
One.
No, that's not. Yes, that Sammy was the problem thing. 1 minus x plus x.
Well, technically it is.
No, yeah.
Because you can cancel out.
I agree. But yeah, x to the x is cancelled out. That's what I meant. So that's the limit as x goes to 0 of minus ln of x plus 1 over x times ln of x plus 1 over x. I'm laughing because I saw the numerator. Can you see what happens to the numerator here?
It goes to ln of x plus x plus 1. X ln of x plus x plus 1. That's it.
But what's ln of x when x goes to 0?
Minus infinity.
Yeah, so the numerator goes to infinity. So if the denominator goes to infinity,
L'Hopital
then it will
again.
be L'Hopital again. But I don't think that's what happens. In the meantime, I gone over in my head about the numerator. I think it goes to 1. So here we have minus ln of x minus 1 over x ln of x plus 1. So this, luckily, we did a moment ago. This goes to 0. I'll show you when. Here. The x ln x goes to 0. So this goes to 0. This obviously goes to 0. The whole denominator goes to 0. So altogether we have infinity in the numerator and 1 in the denominator, which is altogether infinity. Ta-da! Okay, now let's GPT it.
I mean,
test for the.
also you have the answer here, but that works.
Yeah, it is. But also I wonder, it's because it might have been that I've gone over not to the best place. I'm not sure, to be honest.
I mean,
One too many buttons.
There is a full answer.
kind of.
So they did x to the x is 1, and then they said the 0 over the. Yeah, it's a bit easier. It's a bit easier. That was my other option.
Then B.
But it's not much easier.
Wait, 03 is better than 40.
Yes.
They just made things.
Well, and they just
Use advanced reasoning.
That's advanced reasoning. That's like saying
This is great for most tests.
But that's what I was using actually.
And then it starts doing that in order to cheat. It is true mathematically, but fine.
approximations.
Yeah, but it doesn't approximate using the big O notation, and that's Peano series and Taylor series. There is math behind it.
I mean, what you can write should change what it says. It's just like do only using calc 1 without Taylor series and it should works.
Yeah.
I just started with them with like the X file and then just said use only stuff that means custom.
Did it help?
You pay the big AI
No,
over.
no, not today, but I still work out.
I mean, sure.
Okay. So. Next question, Thomas. You came up with a question. Do you have another?
Let's see. What horrible thing you rather wrote 2023 with news? I mean, I'd like to think you won't ask a question like this, but honestly, I don't know anymore. Shalahat.
Yeah, I don't love these questions. Yeah, I'll skip it. I won't ask. Exactly. It is solvable in the way I taught you, but in the way I taught you, it would be a bit long.
Cumbersome.
Yeah. Series with factorial. Do you have something specific?
What this one is the dice field.
Okay, 2 and just second. I think that's a hard one from the homework.
No, it's not one of the tests from the beginning.
What
I mean,
right?
I mean, I get the solution. It's just.
Oh, and wait, it's 2n factorial over n factorial squared.
Yes.
Yeah, over 4 to the power of n times 10 to the power of n.
So the thing is that the ratio test comes out 1, but it's bigger than 1.
So
Yeah, okay, so
answer-
it's not hard, but
cumbersome.
no, but it's tricky, I would say. But if you reverse it, I'm not sure I will be able to solve it just as much. Maybe we could try it. I'm not sure if it's a waste of both our times. But in any case, let's try it. So first of all, I have no idea as to how to calculate the limit. You have to know sometimes how to skip step 1. When I'm trying to do the limit, I have infinity over infinity and infinity. What would you usually like to do? You would like to do L'Hopital, but when you have factorial, you cannot use L'Hopital. So the next option is the ratio test. So altogether, I will go straight to the ratio test.
I know the answer, but it takes like a lot of manipulation.
Yeah. It's a thing, yes.
Let's do a solution. We will calculate the ratio. an plus 1 over an, which equals and 2n plus 1 factorial 4 to the n plus 1
Oh, yeah.
n plus 1 and factorial squared times the inverse 4n and factorial squared 2n factorial, which equals 2n factorial times 2n plus 1 times 2n plus 2 times, that's it, over 4 times no, I need to do, I wanted to do another step. So I think the 4 is fine. I'll leave the 4 and I'll leave the times n factorial squared. And here n factorial times n plus 1 factorial times 2n factorial. I feel like I'm cursing over and over. Factorial this. Okay. Okay. So this cancels out, this cancels out, and we are left with 2, and I'll take the n out. N times 2 plus 1 over n times, so it's n squared, times 2 plus 2 over n over 4 times n plus 1 squared. Okay, this goes to 1 basically. I'm changing it up. I think in this case, because it goes to 1, one can prove it the way I just did before. I'll write it on the side because I wish to look at it this way. So this equals to n squared times 2 plus 1 over n times 2 plus 2 over n.
I can give you the result.
No, it's not the result of what? The limit is 1, I know it. No, I'm just showing you, I'm showing you how to work correctly. And times 1 plus 1 over n squared. Okay, so the limit is 1. It's actually 4 over 4, which is 1. Agreed? N squared is cancelled out. And this is 1, this is 2, this is 2, and this is 1. Okay, write 2 times. Okay. But is it bigger than 1 or smaller than 1? And does it matter? So if it's smaller than 1, it does not matter, and I hope it's not the case. But if it's bigger than 1, then it will be great. And let's check it out. This equals 4n squared plus 6n plus 2 over 4n squared plus 8n plus 1, right? No, plus 4.
Small.
Oh,
This is why it's.
yes, this is smaller than 1, and the limit is 1. So we failed miserably.
But
Ah.
judging by your reaction, we're not gonna ask something like this.
Theoretically, because I'm not even sure how to solve it yet, right? You need to know how to solve it because I can say if it's too hard, right? So I'm not sure and how to solve it.
I'll tell you what it says, and you can just.
What if you're not sure how to solve it, then it is too hard.
No, not Not definitely. I didn't get to think about it too much.
The full solution. Like, basically, you know that 4 to the n is equal to 2 to the n, which is the same as saying you have 2 to the n times 2 to the n,
Yeah.
and you also have n factorial times n factorial. So you can separate them, and like that you get one series which is 2, 4, 6, and then you can divide it with the half of
Yes,
the
and
numbers.
then what?
And then you the rest you have is 1/2, 3.
What test do you use at the end?
You use comparison test with 1/2n, which is this is bigger than 1/2n, which is means that it's divergent.
I'll do it quickly to see, but yeah, I think it's very tricky. So what we're doing here, we're
I don't care
saying
about the fact that it's below 1. That's part of the rule.
it's not helpful. If it was bigger than 1, then I would have said this sequence is increasing. That's why it does not tend to 0. That's why the series diverge. That would have been my
So it tends to, because it tends to 1 and it's lower than 1,
then I have nothing to say.
because it's increasing.
It's decreasing, but not very fast.
What do you mean it's decreasing? If it's lower than 1 but tends to 1, then it's increasing.
The ratio.
No, the ratio is increasing, but the sequence itself is decreasing because that's the ratio.
Oh,
An plus 1/an is smaller than 1. That's what I wanted. Okay, so let's do it quickly. You see if I have something smart to say about it. It's 1 times 2 times 3 times and 2n. 2 to the n, 2 to the n, and factorial. And then you would say that the even numbers, so I have the odd numbers here, and 2n minus 1, times the even numbers. And the even numbers are 2 to the n times n factorial. So 2 to the n times n factorial times 2 to the n factorial. And you get 1 times 3 times 5 times 2 to the n minus 1 over 2 to the n factorial, right? Which is what, 2 to the n factorial, and then what?
And then you can separate this in like the division, the multiplication of 1/2, 3/4, 5/6, and like that you can say that the
So you go downstairs, you go 2 times 4 times 2n,
Mm,
which is half times 3/4
Mm.
times 2 to the n minus 1 over 2 to the n,
mm.
which is bigger or smaller than, let's say it's smaller.
It's bigger than 1.
What is it bigger than?
In the end, the last
Show me, because I'm not seeing how that would help.
Can you say that the fact that we're struggling?
No, yeah, I wouldn't put this question. There is another 2 to the n at the end, which I missed. Horrible. I didn't even notice it.
This has calmed me down.
Yeah, obviously, no, it's. Where is it from?
I think Elad wrote it, but
Yeah, I wonder if they showed it. It's from the homework, maybe. I doubt that they expect anyone to do this whole thing without ever seeing it before. Yeah, I had, by the way, all right, there is a solution for it. There exists.
Oh, wait, definitely.
There exists a solution for this problem
Judgment.
not relevant. What?
It's gonna be, that's sort of an approximation that judgment detail, I forgot immediately.
No. I have another way to go about it, but I won't waste your time because it's not in the test. I will just tell you. I don't have the links anymore. In one of the links I show you, there is a theorem that helps for it. That then maybe it would work and it's easier and makes more sense than what they did here. Next question. So the factorial is not the point here, and it's just really that solving it requires a lot of guesswork. Next question. Do you have one?
No, that's as long as my sadness went, but maybe I can find another one.
If not, you can
This one is in the website to pass, that's right. I think we should probably do it by ourselves, like the.
it's the same one. Yeah, okay, fine.
I mean,
But
we should
it's
do it.
on the link as well, but I'll show you because this one is it's also a bit tricky, but it's nice. I wonder if I can solve it without a trick. I know the trick for that one, and it's shorter, but okay. So question. And we have the sum of the n roots of n minus 1.
And that goes to 0.
Yes. So this bug here, it went all the way. Okay. So first of all, it's a positive. This is a positive series. So we go straight for the Spock. What kind of Spock test do you think will fit here? Now I've thought about it without the trick. Maybe I'll show you the trick later, but now I think that you can do it without any tricks.
I mean, you can. I mean, a comparison maybe.
If you have ratio and root tests are horrible here, so it's obviously a comparison. And if I'm not sure what is the comparison, then I do limit comparison. And the question is who to compare to. So if you're not sure, you need to guess. What is always your first guess?
1 over n.
The harmonic, exactly. Okay, I'm teaching you how to think about these things. Okay. By the way, if we tried a comparison here with 1 over n, is the limit calculable? No, I think the problem is doing the limit here. Okay, whatever. We will try to compare to the harmonic theory. So I'm trying to find the limit of the n root of n minus 1 over 1 over n. Agreed? Okay. What is the limit?
It goes. You basically do 1 over n plus n, like the exponent, right?
What?
You know that the exponent, like the top part is n to the power of 1 over n.
So I'll write it as an exponent minus 1 over 1 over n. Yes.
Then you multiply by n. You multiply by n.
You use the level for
What?
actually level.
But why? What is my next step? So you took a step backward. If I would multiply by n, I would get infinity minus infinity, which is unclear. So I don't like that you
Well,
didn't
say
do
multiply by
the
n.
first step. The first step in limits is finding out where does everything tends to. 1 over n goes to 0. What about the n root of n?
1.
Is 1. Minus 1 is 0. We have 0 over 0. Lopitalize it. Okay.
When in question,
And it's easier for me to write x equals 1 over n using Heine. And we look at the limit as x goes to 0 on the right of 1 over x to the power of x.
Zero is a problematic case. So
Yes.
it is.
Yes, but this is known. The square root, the n root of n. It's known.
It's zero now.
Yeah, but it's known specifically that it's 1. It was one of the first things we used the quotient rule to prove. But yes, um, we get 1 over x to the power of x minus 1 over x. Agreed?
okay.
Funnily enough,
Using the Taylor rule have been in the end.
that's exactly or that's exactly. Was it on the same test? I wonder if it was a hint.
I think
Over the years, how many questions do you think just repeat themselves?
a lot. Someone complained about it, and in fact, everybody is there.
Yeah.
Yeah, it was in the same test.
Yeah. So that was a hint. So this was nice. And
But
what was the limit? Infinity. Which is infinity.
No, wait, that makes sense because we didn't even have to do anything after the first one because there's no problematic case. We know that n root of n is 1. Oh no, wait, that's different.
wait. Why?
So it's infinity. Wait, so what does it tell us? Our series is bigger
That's it.
than the harmonic and therefore diverge.
So
So I'm thinking my trick is nicer. I'll show you it in a bit, but that's
funny.
funny,
Anyway,
yes.
I don't know if we saw a lot of how you can just decide that x is 1 over n, and it's like
That's Heine. That's Heine.
yes, I mean
So that's it. If the limit is 0, then for every sequence that goes to 0 plus, if the limit is infinity, then for every sequence I will plug in, I will get the same limit. So the actual passage is from below to above. I know this is the limit. Therefore, I'm allowed to plug in x equals 1 over n, and I will get the same limit. It's the definition of limit by Heine. Okay, that's the answer how to do it. Just plug in any sequence in the world you like that goes to 0, and the limit will be the same. So a trick for the question above, I will go straight to compare these two. That means that the square root of n is bigger than 1 plus 1 over n. Oops, I just the n root. That means that n is larger than 1 plus 1 over n to the n. What can you say about that?
that goes to e.
The right hand side is bounded. The right hand side is bounded. And it's bounded by E. It doesn't matter, by the way, if it's bounded by E or anything else. It converges, then it's bounded. Therefore, the left hand side will be larger eventually.
Mm.
From some point forward, I guess. So yes, so this is larger. That was much shorter, right?
Why can't we say it's bigger than 1/n?
No, that's the question. This is the
Ah.
proof.
Okay.
So here is it or is it? Right? And the answer is yes. Okay, no questions. Next. And yes.
1 plus 1/n to the n is that positive thing is an increase in series.
It's increasing and goes to E. But it doesn't matter if it's increasing or decreasing, it goes to E, it has a finite limit, therefore it's bounded, and n will eventually surpass any bound and stay above it. Any other questions?
Any other questions?
Any other subject? I feel like we've prepared for like 2 questions. Oh well, that's the whole course. And we prepared for like 2 questions out of the 5.
I mean,
I wouldn't mind.
analysis for
Yeah, analysis.
Okay. Do you know this? Because that's
I mean, I didn't
Order.
see any questions about the what I looked, but I'm not sure.
I gave you in engineering,
Yeah.
40 of them,
Is it
and
the
I
one-
told you it will be on the test.
Is it the one with the 69?
What?
There was an exam in the drive, the first one, same one, where the factorial was. The last question was this.
I mean, open one of yours and we'll see.
No.
A n equals.
Yeah, this is kind of one. You know how to solve this?
Substitute.
No, horrible.
Yeah.
You'll all fail. That's why I'm trying to save you from it. Let me give you the example because what you did is horrible. It's like close to 0 points. And tell me the example. I will solve it. You need to
A
know.
to the an equals n over.
A1 is some constant, 69,420,
This
and then
one. Wait, is this
No.
one?
no. That's what's written on the exam.
Wait. Yeah,
Just written 69.
Wait, is it A or is it B?
the,
B.
the one that has the funny number.
Yes, 69%. This is it.
How could you miss it?
I don't know. The explanation is in the middle.
Yes. So AN is some number, I don't think it matters a lot. And AN plus 1
If only 69% it works.
is the third times 2AN plus 5 over AN squared. You really need to solve these kind of exercises. I gave you a lot. Question number 5 in engineering. So the question is whether is this sequence converge, and if so, what is its limits? Or in general, what is the limit of AN? That's the question. Okay. The way we go about it usually is to prove whether probably I need it's positive. It will be funny if it will be funny if it's actually true only for that number,
Yeah,
but I very much doubt it.
we find that the limit is at 69,419 and it just goes to infinity.
Yeah. It could be. Okay, I'll write the number because it might matter. It might matter.
It's very important. Actually.
Okay.
We want to prove first if it's
So we see if it's monotone, and if so, we need to see if it's bounded. We don't simply write L equal L and that's it.
yeah.
Ah.
First we divide that
So
n plus 1 over an.
so I don't usually divide first, and I will not do this here as well. I always start with a subtraction. The reason for me to divide is only if an is a common factor here and it's easy to divide, and then it's reasonable to start with division. Maybe it will be what's needed to be done, but I'll start with an plus 1 minus an equals. So 2/3 of an an plus 5/3 over 1 over an squared minus an, which is 2/3 of an an. No, I'm just writing. Yes, it's a third. I'll take it out now, and I will remain with minus an. So it's 5 over an squared minus an. Agreed? Which is 1/3 over 5 minus an cubed over an squared. Agreed?
Yeah.
So the series appear to be decreasing at first, but is it always decreasing? So my question is basically the sequence increase when, if and only if, for every n 5 minus, I think is do that 5 minus an cubed is positive.
I think that it's like it's I'm not really that's just no. Because an squared is always positive. So an like a1 will be whatever number, it's 5 minus whatever number, then it will go to negative, and then the next one.
Did you not look at the solution, by the way?
Yeah.
Okay, so let's try it. It could be switching, and then we'll have to do something even more horrible than that. But first of all, that's the truth. Okay. And we are not sure if that is positive. At first, it's negative, right? So it will be decreasing at the first step. But maybe at some point it will arrive here and keep increasing, right? We're not sure. So what do we do next? We are not sure. We will try to calculate the limit if such limit exists. A lot of the times it gives us a frame of reference and guesses as to how to continue. Okay? So we're saying the next, and that's what we do always and not always, but a lot of times the question. We say the following: say, if
Assume the limit exists.
Okay, I deleted the entire course. I don't know. I just created a new document. Okay.
Another course?
If yes. That's what you do after you pass the test, right? Okay. If not bold enough, because it's not bold at all. If yes. Oh, I did italic instead of bold because I tried to do bold before and I got to new. Whatever. If an the sequence an has a finite limit L, then we can calculate the limits of both sides of an plus 1 equals to that horrible thing. And then you get L equals, that's exactly what I did. L equals, it is a part of the question, just the whole, not the whole thing.
The rest I just forgot.
Oh, you read, great. That's exactly how you prepare for a test.
Just 3.
I did, was it South Park? Oh no, why wouldn't it read? Whatever. Okay, so we got this. And we'll solve it. And we get 0 equals
I think
5 over L squared
maybe it's better to divide this guys.
minus, no,
It's just-
minus L which means that L cubed equals 5, which means that L equals the cube root.
why minus L?
5. It's just a calculation I did before. Move L to the right, make it into 3L, put it within the parentheses.
Ah,
Some algebra mumbo jumbo.
okay.
Okay, but I did quickly because I did the exact same thing a few minutes ago here. It's that. Just with the letter L written everywhere. Fine.
That's right, sure.
And I also skipped the step here. Okay, so that's that. So this gives us an idea. Maybe an is larger than the cube root of 5 always, and therefore the series, the sequence decrease. You see, because we found out not so long ago that if an is larger than the cube root of 5, then this is negative and the series decrease. Maybe it's always bigger than that, and the limit is actually the cube root of 5, which I think it's actually the answer here, right? So how can we tell that it's, how can we prove or tell that it's always bigger than the cube root of 5? Induction.
Okay.
We will prove that. And I have many tricks around this subject. That's why you have to solve, or at least read a lot of the question in engineering. It was so silly to say, but it wasn't on past test. I'm the lecturer. I'm telling you it's on the test. No, I'm guessing it's not. It's never on test.
What part?
The sequences with the recursion.
No, not what I meant. I meant that I didn't see it when I looked at them.
What do you mean?
Because maybe I missed it, and that can be true. But I
You
just
look
like
at it like this. I open an engineering test. Where is it? In the air, I'm not even looking, I'm not even seeing the tests. I doubt that there exist.
I don't remember hearing about them.
It's- I'm going to engineering tests. I'm opening a random one. There, you see, that's what happened. It simply walks away. I'm not seeing that.
I'm not accepting this future.
And I'm looking at question number 5. And I open a random one. In all of them, question number 5 is of that nature.
I'm still doubtful.
Solve it, for heaven's sake. Question number 5 will help you, number 1 will help you with question number 1. Question number 5 here will help you with question number 3 on your test. Series, we did a lot of them now. And analysis, it's question number 3, mostly on these tests that will help you prepare. And just do it.
Yeah, sounds like you're
It's
okay.
so silly that you're opening the drive for a course by another lecturer.
I mean, in my defense, I thought that the courses were equivalent, but okay.
Even if it is, it doesn't matter. I wrote the test. I'm telling you what I put on it. It's not a philosophical, theoretical question.
Here, take money. I'm telling you how to do the test. Oh, no, it's not.
Yes. So I was like, I'm thinking of a number between 1 and 10. The number is 7. Can you guess what the number is?
60,900 or 120.
But every number has the same probability. How can I know? Okay. Okay. I hope at least that I was clear about that. So we will try to prove that by induction. If it's not the case, by the way, if it's sometimes smaller than that, then the series decrease, that would be horrible if that's the situation. So hopefully the induction will succeed. And so A1, it was actually important, by the way. A1 being 69 ACAB 420 is larger than the cube root of 5, I'm pretty sure. Now assume
Why not just do A2 instead of going directly to the inductive step?
say why don't do an extra
Yeah,
redundant step.
no, I mean, yeah, but if you prove, if you prove,
Thomas, the answer is within the question. Why don't do an unnecessary step?
I mean,
Because I don't work that way. I'm trying to be efficient and reasonable.
yeah, but the only thing you're trying to prove is it never goes under that number.
Yeah, so if we did on the second step, that's not induction. That's the proof that 9 is a prime number. Why? 3 is prime, I added 2, 5 is prime, I added 2, 7 is prime. Look, I even made more steps. No. I don't see any reason to do the first step as giving it the aura as more important than any other one. As- yes. Assume an is larger than the cube root of 5. We need to prove that the next element is larger than the cube root of 5. Indeed, I always like to write indeed as if I succeeded already. Indeed, an plus 1 equals, equals too soon. So we need to prove that, what is it? Shalva, no, thanks, but I never guessed. I think they changed the Shalva used to be in transparent packaging.
Just wait for. Pretty thanks.
First of all, I wrote it one time, and the second time will be to switch an plus 1 by a third times 2an plus 5 over an squared. Larger than the cubed root of 5. Agreed?
Mm.
So what do we do here? I have no idea. And
We can just change an with this cube root of 5 maybe.
Multiply.
Okay, so the false way to go about it
Is what I was
is
saying.
in induction, simply plug in again as if the induction assumption was equality. If the induction assumption was equality, then yes, definitely I could have plugged it in. But if I replace an by this number, I'm lowering it. So for an, it will replace it by something lower, which is fine. But here, because we reduce the denominator, we increase the whole thing. So I cannot simply plug it in. There are a few ways to go about it. Now I'm having one thought. I will multiply by 3 first, and I will do common denominator. So here we'll have 2an cubed plus 5 over an squared. Is it, that's a question mark, 5 times 3 times, sorry, the cubed root of 5. Is that true or not? I'll multiply by an squared, so it's 2 times an cubed plus 5. Is that bigger than 3 times the cube root of 5 times an squared? So it's 2 times and no, not 2 times, an times 2 times, no, sorry, an squared times and an 2 times an minus 3 times the cube root of 5 plus 5 ought to be bigger than 0. Agreed? And now I think I will go with this, because now I have the induction assumption.
Oh, that's interesting. How they did it.
How they did it?
Yeah. Because this.
Oh, horrible. They use
That's my idea.
the algebraic average and geometric average, the AMGM. I'm so surprised at this thing. I'm pretty sure they've seen it in homework. Students don't think about these things spontaneously. Okay, So let's look at that. By the induction step, or by the assumption, this, and it is the kind of question I do ask, right? The solution there is tricky, but this solution is straightforward. So this is larger than 2 times this cubed root of 5 minus 3 times the cubed root of 5, which is minus the cubed root of 5. I hoped it would be a positive number, yet it is not. And does that help me at all? This is larger than that. an squared is larger than the cubed root squared. So altogether, the product, what can I say about that?
But it's very ugly.
Oh, wait.
It's negative. One side is negative for sure, and the other one is positive for sure.
No, but you have. It's bigger than 0 because you'll have.
It's smaller than -5
Yeah,
or
because
bigger than -5. That's what I'm not sure about, because this is negative. So the
No, no,
inverse.
but in the end, at the very least, you multiply negative.
Wait a second. I'll do it the other way around. This minus 2 times an. No, because this, but then this would be smaller. No, it does not work. No. I can do something horrible here.
But it seems like it should work.
Seems like, but it doesn't. Let me think, what else can we do? So horrible that they did that.
I think the only reasonable answer is what they wrote, which is stupid, but whatever.
No, but if it's that, then I wouldn't have asked it. But I'm trying to see whether we can prove it's always bigger than the cube root of 5 in another way. Let me think about it for 2 more seconds.
Random what you do.
Okay,
Substitute.
so I'm not sure it will work. If it doesn't, I will delete it, because I won't delete it. I'll say this is a step that you would not need to do because it's too hard. But I will tell you in general what do we need to do. This is an inequality. How do we analyze inequalities in calculus? Using analyzing. So let's look at this as a function again. Okay. Let's look at the function f of x equals x squared times 2 times x minus 3 times the cubed root of x plus 5. A minute before I will actually solve it, I wish to show you it on GeoGebra. The question only is whether we could analyze it ourselves. So I didn't work the copy paste, let's write it. F of x equal x squared times 2 times x minus 3 times 5 to the power 5 to the power of a third plus 5. Okay. So that is the function. We need to prove that it's positive. Obviously, it's positive, right? But how do we know that's the way it looks? Okay? Try to stay with me. I know it was a long exercise, but on the way, I'll write as a new exercise, okay? Because that's one of the things I wish to teach you in calculus in a course in general. I'm stuck with algebra that I don't know how to do, and a lot of time calculus is the way to solve it. So I wish to know that this inequality holds. I know that an is larger than the cubed root of 5. Looking at the GeoGebra, I noticed that it's even probably this, by the way, x equals 5 to the power of a third. Yes, that's exactly that. So actually, in the cube root of 5, it's exactly 0. And if I put any number above it, it's positive, right? So if I can prove and get to this drawing myself, in the test we don't have GeoGebra, if I'm able to do it myself, then I can go back and say, by our assumption, we know that the previous element is larger than a cube root of 5. Therefore, when we plug it into this function, it's positive and we're done, right? So what I'm going to do as such. For every x larger than the cube root of 5, f of x is positive, and therefore we are done. So what I'm doing now, I'll let you question if you want, but what I wish to do is I'll do this as another exercise, which I'm pretty sure is straightforward and not that hard, to be honest. You will see it in a second. But I wish to finish first that exercise. So for now, I'm assuming that we've proved it, and the sequence is always, and I'll do a review in a second. Any questions before I go on? Yes, Sam.
Why were we originally proving that the sequences?
Okay, so that's the recap. Okay, so now listen up. That's the recap. You can forget the problems we had. Now you can see the whole process. And what?
My friend sent me what his solution was, and Elad wrote what you would have wrote too.
הצבת ערך קטן יותר ומכנה מגדיר, הצבת ערך לא נתן לו משהו, כן. But he just took out 2.5 points off. So he wrote nonsense and he got most of the points. That will not happen in my test.
God damn it.
Yes, okay. Yes. Okay, so recap. What's the question? I have a sequence. It has a first element. It has a recursion step. And we wish to find the limit of that sequence. So because we know that's the idea in this type of question, we go straight to the monotonic idea. We wish to see the difference between two consecutive elements and see whether it's always positive or always negative, whether the sequence is always decreasing or always increasing. So I took the difference, I did some algebra, I got to this expression, and here easily I find that if an is smaller than the cubed root, it's decreasing. If an it's wait sorry that way. If an is smaller than the cube root, it's increasing because it's positive. And if an is bigger than the cube root of 5, it's decreasing. So I replace the question in whether the sequence is always larger than the cube root of 5. I try to do it with induction, and I did this step. It wasn't completely necessary. Now, when I'm thinking about it, I could have explained it the way I did, but I also said that if a limit exists, it must be that. Okay, so altogether, I'm thinking if an is always bigger than the cube root of 5, then the series is always decreasing. And now I'm going to write the rest. Since for every n, it is true that an is larger than the cube root of 5. We saw that an decrease. That's above, that's from that, right? If an is bigger than the cube root of 5, then this is negative, okay? And next, what do we do if we know the sequence decrease? Does it mean that it has a finite limit?
We knew that it's at the cube root of 5 now, so if it
No, that's super important. Notice that I never said that it's the limit. That's why I said if it has a finite limit, then the limit is. But
No.
who says it has a finite limit?
no, I mean if it has a final limit and it's decreasing, then
No, but how do we know? We proved that it's decreasing without any assumption. Does it mean that it has to have a finite limit?
not necessarily.
But what is the main theorem that I always ask about in this kind of question? What does the theorem say?
If it's increasing with bounded.
And bounded.
Yeah.
So that's what you need to think about. Is this sequence definitely bounded? Yes, we've just proved it. Since the sequence is bounded from below by the cubed root of 5, it has a finite limit. Here, listen well, guys. This is what I expect in order to get points in this question. I'm not checking whether you are able to switch sequences by L and solve simple quadratic equations. Here it's in power 3, so it's hard. This is not the question. The question has to do with this sentence here. I need to prove whether it's increasing or decreasing. I need to prove whether it's bounded or unbounded. I need to say if it's bounded, that's the limit. Maybe it's possible, maybe it's not possible. There are 40 odd questions in engineering of the type. Make sure to go over it so you get the 322 points on the test for this question. If you don't, I have a lot of experience with it. You lose the 22 points because people say they put L, says this is the limit. Done.
Isn't that what we
Okay.
did on the
Yes.
the quiz?
Yes.
Either
Wait, Sammy, sorry. So since it is bound, it has a finite limit. And we've shown before that given that the sequence has a finite limit, the limit must be the cubed root of 5. And last general comment, it's not always this structure 1, 2, 3. These are this type of arguments, but it each question it could be something else. In the lecture, by the way, I showed you an example where the limit was impossible and therefore we decided that it's unbounded. And sometimes there are a few limits and I need to figure out which of them is the true limit, right? It's the type of questions, okay? Now you can ask me a question and then I will do this as an analyzing question to find out when is it positive in order to solve this equation, this inequality, sorry, of degree 3 of the variable. Yes, Sam.
With the rule about having an existing, it's either if it's decreasing in bounded from below or increasing in bounded from above.
Exactly. And why? Because once it's monotone, one of the bounds is obvious. If it's increasing, it's obvious it's bounded from below by the first element. If it's decreasing, it's obvious it's bounded from above by 69,420. Okay? So
Child.
I'm a child. I didn't write that exam. Okay.
Yeah. He actually wrote the numbers hysterical, but
Yes. Yes. And people went like, haha, and then they tried solving the question.
Crying.
What? I'm guessing. I'm not sure. The using the average theorem here is crazy. I'm not even writing it as a possibility.
what is that theory? I forgot.
Basically, that
The algebraic average is always bigger than the geometric average. Now here he thought about it as an plus 5 over an squared. So I will show you this a second because it is nice. This equals, whoa, an plus 5 over an squared over 3. That's the algebraic average, and that is larger than the geometric average, which is the cubed root of the multiplication an times an times 5 over an squared, which is, surprisingly enough, the cube root of 5. Okay? Note, since AM is larger than DM, then, so that's the proof. 2 seconds. But who would have thought about these 2 seconds? Okay, again, if it was in the homework, then no problem. Lastly, I said, so example, prove that for every x larger than the cubed root of 5, it is true that f of x equals, what was it? This horrible thing?
Not bad.
Yes.
It is.
Is larger than 0. Okay. And actually just doing that as an example is rather easy. Why? A solution. Let's derive what's the derivative of this. So it's 6 times x cubed
Squared.
yes, what I wrote is true. It's 6 times x squared minus 6 times this third root of 5 times x. That's it. And now that's a parabola. and that equals x times 6x times x minus the cube root of 5. And now, if x is larger than the cubed root of 5, what does it say about the derivative?
Positive.
It's positive. Therefore, the function increase. So how can I know it's positive or not? I plug it in. F of the cube root of 5 is very easily shown to be 0. Okay, because that's minus the cube root times the cube root squared. Altogether, it's minus 5 plus 5 is 0. And therefore, since f increases for every x bigger than the cubed root of 5, it is true that f of x is larger than 0.
How? Like,
And see how easy that was.
Not necessarily.
how does it make
What?
sense?
No, just that. I didn't say the whole question.
Ah,
But this is super easy.
right.
It's just like 5 yechidot level, right? I take the function, I derive it, I find the zeros of the derivative. I can do even shitat hatavla if you know it, plug in numbers in between and see if it's positive or negative, and find out when does it increase and what are the values. This was algebraically sound.
Not necessarily, because
What not necessarily? Wait, what are you saying not necessarily about?
no, because you have to calculate the second turning point. Because the second
No,
turning point.
no. The derivative promises me that the function increases from the cube root of 5 onwards. Do you agree about that?
Why?
Because if x is larger than the cube root of 5, this is positive.
Okay, right, sorry, my bad.
Okay. But I did go over it fast, right? I did in my head. But yeah, it's increasing and it starts in 0, then it will be bigger than 0. That's my point. I might be able to, I might have, should have, it might be that I should have calculated the signs of the derivative slowlier. But I was so happy because it was a parabola and I know exactly when it's above the axis and when it's below the axis that I knew it's easy. So I went forward, but I should have done it slower, but it's still easy. And if you go to the GeoGebra, you see the roots 0 and the cube root of 5 are exactly the points when I switch from increasing to decreasing, right? The function increase, then decrease, and then increase. And I can plug in the minimal and maximal points to find out exactly the values. And if I need to know where does it go to, I could have calculated the limit as well. Here I stopped exactly when I needed to for the question, because that's my idea of analysis, being able to solve the question needed. So it's not as elegant as this 2 seconds theorem solution, but this is a solution that shows you've learned the subject. And if you notice, we did it twice today even, to go to the function and study it. Any other question?
When's Modbet?
Yes. I distinctly remember Thomas saying, Linear is hard. In calculus, that's easy. We know what to do. And now linear is best.
I think you're misremembering. what
You
I-
said that in calculus, you know, you have preparation exams and you have where to study from, and in linear you don't.
I said linear is easier.
Yeah,
Yeah,
because you don't study linear.
Yeah.
Because it's the only thing I.
There is no reason you shouldn't pass this test, but you do need, for the love of God, to listen to me and solve the question I told you to solve. And now I'm saying that I told you this like in mid-semester. Now the test is 3 days away and you still did not do it.
I started looking. I just didn't find series because I'm dumb. But like that's
No, series there wasn't there, I agree. But this is not series, this is monotone sequences.
no, that I did.
How much is a?
But that
lifeline?
we're talking about. No, just series, if that's all the problem, that's no problem. Series, okay, so series we did today. But that is there's a screw here that comes out of the sure.
It's
Okay.
fun.
It's good that it's not one of those office ones that, you know, if the piston shoots out.
Yeah.
Oh, it's fun.
That's a meme one, not an actual
It is
fun.
cool. Like, some very cheap ones, like they don't have like a metal section thing above it. But
Wow.
that does have like this one.
They survive that.
Okay, it will be fine,
We'll all die, but we'll die happy.
How
but
much-
we'll die slowly.
How much is a lifeline?
From what?
How much does it cost?
Ah,
to
for
come
money,
as
you
a
mean? No. For guys who pick up 30 agot bottles and being excited, I don't think you're in the
I can
ballpark.
afford 3 bottles.
Yeah, the liter, a liter and a half one, the big one.